Valid logical statements. A logical statement is valid if it is always true regardless of the truth values of its component parts. To test the validity of a compound statement, construct a truth table to analyze all possible outcomes. If the last column, representing the complete statement, contains only true values, the statement is valid. So let's take a look at example truth tables number 2. Construct a truth table to determine the validity of the following statement. Not, parentheses, P and not P, close parentheses. So the headers that we have on this table are P, then not P, then P and not P, and then not, parentheses, P and not P, close parentheses. Because we have one logical statement to work with, we only have P, and the two possible values for P are true and false, which means the values for the not P column are false and true, which means the values for P and not P, because and requires both statements to be true, we're looking at the columns P and not P, both of those statements are going to be false. Both rows are going to be false because there is no row that includes two trues in those columns. And finally, we have the completed statement, not, parentheses, P and not P, close parentheses. So we find ourselves looking at the third column, P and not P. We're writing the negation of those values, so that would be true and true. Now, because this final column representing our complete statement is completely true, this is a valid statement. Example, truth values number 3. Complete the truth table for not P or not Q. So once again, our column headers are going to build to this complete statement. The first two are P and Q. Then we have the necessary not P, then the necessary not Q, and then the or of those two, the not P or not Q. The first two columns are completed for us, true and true, true and false, false and true, false and false. For the third column, we look at the column that's P to find not P, writing the negation of those values, which means that the third column is false, false, true, true, because it's a negation of the first column. For the fourth column, we're finding the negation of the second column, which makes those values false, true, false, true. For our completed statement, our last column, not P or not Q, we are looking at the third and fourth columns, and we're looking at these as an OR. So false or false is a false statement because there is no true between the two. The next row, we have one true, so it's true. Third row, we have one true, so it's true. And the last column, two trues, so therefore it is true. So the final column for not P or not Q is false, true, true, true. Example, truth tables number 4. Construct the truth table for not, parentheses, P or Q, close parentheses. The column headers are P and Q, and the other two are blank. So we need to write in the statements that are going to build up to the completed statement. This means, in order to have the complete statement, which I'm going to go ahead and put as the last column, not, parentheses, P or Q, in order to find the truth value of this statement, we simply need to know what P or Q is. So I'm going to go ahead and write that. So the third column header is P or Q, and the fourth is not, parentheses, P or Q, close parentheses. Now we have our rows, first two columns filled out as true, true and true, true and false, false and true, false and false. So that we can then complete P or Q looking at those two. If there is any true, then the OR is true. So the third column is true, 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 false. And the fourth column, not, parentheses, P or Q, close parentheses, is the negation of column 3 so that it produces false, 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 true. And that is the truth table for that statement. Example, truth tables number 5. Construct the truth table for not, parentheses, P or not Q, close parentheses. Once again, we have the column headers as P, then Q, and the rest are blank. So for these to build to our completed statement, the third column header needs to be not Q. The fourth column header needs to be P or not Q. And the final header needs to be the completed statement, not, parentheses, P or not Q, close parentheses. Our rows for the first two columns are completed as true and true, true and false, false and true, false and false. For the third column, we need to look at the column Q to find the negation of Q. So if we find the negation of these values, this third column is false, true, false, true. For the fourth column, we need to look at the columns P and not Q, and we're looking at these as an OR statement. So we're looking at the first and the third columns, and we're thinking OR. So if there's a true in either one of those rows, first row, then our next value is going to be a true. So there is a true in that one, so our fourth column, first value is true. There are two trues in the next column, or the next row, so that's true. There are no trues in those two columns for the third one, so that is false. And there's one true in the last, so that is true. For the fifth column, we're finding the negation of the previous column, so we can just look at that column and fill these in as false, false, true, false. So the final column for not, parentheses, P or Q, P or not Q, close parentheses, is false, false, true, false. Think about the column headers as you are working on problems like these. They must build to the completed statement, and then so that we can use previous columns to fill those in.